On July 20, 1969, the world watched in awe as Apollo 11 achieved the impossible, landing humans on the moon for the first time in history. This was more than a scientific breakthrough. It was a defining moment for human civilization. The mission was born out of political rivalry, technological ambition, and sheer human determination. With the Cold War fueling the space race, the United States was determined to outpace the Soviet Union and prove its dominance in space exploration. What began as a challenge by President John F. Kennedy in 1961 became an unprecedented feat of engineering and courage. Astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins embarked on a mission that would forever change our understanding of space. Apollo 11 was not just about reaching the moon. It was about proving that humanity's potential knows no bounds. The next step, exploring beyond, the journey was just beginning. The Apollo 11 mission was not just a scientific and political milestone. It was also a deeply personal journey for those involved. Buzz Aldrin, one of the key figures in this mission, had a fascinating story leading up to his moment on the moon. Buzz Aldrin, the man behind the helmet, was not just an astronaut. He was a visionary engineer, skilled pilot, and a pioneer in space navigation. Born as Edwin Eugene Aldrin Jr., he grew up in a military household that valued education and discipline. Inspired by his father, an aviation pioneer, Aldrin pursued an education in aerospace engineering, graduating third in his class from West Point. His deep curiosity about space mechanics would later play a crucial role in his contributions to space travel. Before joining NASA, Aldrin had already demonstrated courage and intelligence as a fighter pilot in the Korean War, flying 66 combat missions. His experience in high-stress environments gave him the calmness needed for space travel. After the war, he pursued a doctorate in astronautics from MIT, specializing in orbital docking and spacecraft maneuvering. His groundbreaking research helped develop techniques that were essential for Apollo 11's lunar landing and return journey. When Aldrin joined NASA in 1963, he quickly proved himself as one of the most technically skilled astronauts. His expertise in spacewalk procedures and orbital mechanics made him a valuable asset in planning the mission. Though Armstrong would take the first step on the moon, Aldrin's role in Apollo 11 was just as vital, ensuring that the landing and return were executed flawlessly. His legacy extends beyond Apollo 11, as he continued to shape space exploration long after the mission ended. With the Apollo 11 crew ready and the mission objective set, all that remained was the launch. The world watched in anticipation as history prepared to unfold. The historic launch, Apollo 11, takes flight on July 16, 1969, at 9:32 a.m. EDT. The mighty Saturn V rocket roared to life at Kennedy Space Center, carrying Apollo 11 on its journey to the moon. Millions of people across the world watched as the rocket ascended, marking one of the greatest technological achievements in human history. The launch was flawless, with all systems functioning as expected. The astronauts were now on their way to making history. The journey to the moon took 4 days, during which the crew conducted various critical maneuvers. One of the most important tasks was docking the lunar module Eagle with the command module, Columbia. Armstrong and Aldrin moved into the Eagle, preparing for their descent while Collins remained aboard Columbia in lunar orbit. As they approached the moon, unexpected challenges arose. A series of computer alarms signaled issues in the guidance system, but quick thinking by the astronauts and NASA engineers allowed the mission to continue as planned. On July 20, 1969, as Eagle approached the landing site, Armstrong noticed that the programmed location was too rocky. Taking manual control, he skillfully guided the spacecraft to a safer spot. At 4:17 p.m. EDT, with only 30 seconds of fuel remaining, Armstrong announced the historic words, "Houston Tranquility Base here. The Eagle has landed." With that, humanity had successfully reached another world for the first time. Landing on the moon was an enormous milestone, but now the astronauts faced an even greater challenge, taking the first steps on the lunar surface. The world held its breath. First steps and initial observations at 10:56 p.m. EDT, Neil Armstrong descended the ladder of the lunar module and stepped onto the moon, delivering his legendary words. "That's one small step for man, one giant leap for mankind." The world celebrated as humans had finally set foot on another celestial body. Armstrong's movements were slow and careful, testing how lunar gravity would affect mobility. He then began examining the surface, noting its fine, powdery texture, and how footprints remained imprinted due to the moon's lack of atmosphere. Shortly after, Buzz Aldrin joined him, becoming the second person to walk on the moon. As he looked around, he described the landscape as magnificent desolation. The two astronauts conducted various tasks, including planting the American flag, speaking with President Nixon, and setting up scientific experiments. They also took some of the most iconic photographs in history, capturing images of the moon's surface, their spacecraft, and even each other. Despite the excitement, time was limited. The astronauts had only 2.5 hours for extravehicular activity before they had to re-enter the lunar module. Every movement was meticulously planned. As they collected lunar rock samples, set up seismic instruments to detect moonquakes, and deployed a solar wind experiment, their work would provide invaluable data for future missions, shaping our understanding of the moon's composition and history. Unusual sightings, Aldrin's perspective. While Apollo 11's mission was a scientific triumph, some of the events that took place during the journey left both the astronauts and the public with lingering questions. One of the most intriguing accounts comes from Buzz Aldrin, who later spoke about unexplained lights he observed during the flight to the moon. As the spacecraft made its way through space, Aldrin noticed a mysterious glowing object outside the window. At first, he assumed it could be a piece of the Saturn V rocket, but as they continued to monitor it, the explanation became less clear. During a post-mission debriefing, the astronauts discussed their observations, but NASA chose to keep these conversations out of the public eye. Aldrin later revealed in interviews that they saw something they couldn't immediately identify. NASA, however, explained it as reflections or debris from their spacecraft, a common occurrence in spaceflight. Despite this official explanation, Aldrin's comments over the years have fueled speculation that the Apollo 11 crew may have encountered something beyond our understanding. He has been cautious about fueling conspiracy theories, but has acknowledged that there are many things we still do not fully comprehend about space. His statements have led to countless debates in the UFO and scientific communities. Scientific experiments conducted. Apollo 11 was not just about planting the American flag and taking historic photographs. It was a carefully planned scientific mission. The astronauts had limited time on the lunar surface, but every second was used efficiently to gather data that would expand human knowledge of the moon. One of their key objectives was to monitor seismic activity. They deployed a seismometer to measure potential moonquakes and meteor impacts. The data collected helped scientists understand the internal structure of the moon, confirming that it had a solid crust but lacked tectonic activity similar to Earth. Another crucial experiment involved the solar wind composition experiment, which aimed to collect and analyze particles from the sun. A special aluminum foil sheet was placed on the moon's surface, capturing solar particles that would later be studied on Earth. Perhaps the most famous scientific contribution of Apollo 11 was the collection of lunar soil and rock samples. The astronauts collected 47.5 pounds, 21.5 kilograms of moon rocks, which provided key insights into the moon's composition and geological history. These samples confirmed that the moon had no signs of life, no liquid water, and a surface heavily shaped by meteor impacts over billions of years. The data gathered remains invaluable to scientists today, influencing future lunar and planetary exploration. The far side of the moon. Myths and realities. For centuries, the far side of the moon, often mistakenly called the dark side, was a source of myths and speculation. Because the moon is tidally locked to Earth, one hemisphere is always facing away from us. Before space exploration, some people speculated that hidden civilizations, secret bases, or unknown geological structures might exist there. Apollo 11's observations helped dispel these myths, providing concrete data about the moon's far side. During their mission, the astronauts orbited the moon multiple times, allowing them to observe its hidden hemisphere. What they found was not an alien world, but a heavily cratered barren surface, even more rugged than the near side. The lack of large flat plains like the Sea of Tranquility suggested that lava flow activity on the moon was not uniform, possibly due to differences in crust thickness. These findings added to the growing knowledge about how the moon was formed and why its surface varies so dramatically. Subsequent missions, such as Apollo 15 and Apollo 16, explored these differences in greater detail, confirming that the far side of the moon was geologically unique but not drastically different from the near side.